Beginning of the 19th, we started with roots blowers. The first one as a wooden rotor inside with a leather ceiling. After the Second World War, we started with the screw compressors, oil-free. And then it was modified to go also in process gas.
I heard like you have a compressor in CERN.
In CERN, we have oil-injected screw compressor packages working in a helium process. Similar to the DAISY part, it's also a research and development institute in Germany.
The new technology becomes much easier. It's distance controlled. It's all computerized. It's all networking. Is the same for your technology as well?
The target of the customer is to reduce this people so much as possible. So it should be safe enough that this machine can run.
So imagine, it's night. So you use the natural gas to produce power and you have hydrogen at the same time, while the CO2 you separate. Now it's morning. You start having photovoltaics. When it comes to noon, start producing hydrogen in reverse operation. So you take the surplus photovoltaics and turn it into hydrogen power you can store. So this is the final step for the full decarbonization of the power system, and you integrate your fuel generation also in it. This is a technology for a country with hydrocarbon reserves. So that's the chance for the Middle East to take the lead. Gentlemen, how are we? Welcome back. Earlier on we discussed, and you did it really well. Can you explain the compressor to someone who doesn't know a compressor? Say I've never seen it. I've never held a compressor. You could put one in front of me. I probably wouldn't even know it's called a compressor. How does it simply work?
The compressor is a machine who brings the inlet pressure to the outlet pressure, so to increase this pressure.
So you were saying like a bicycle pump?
Similar to a bicycle pump,
Right.
yes.
I love that. I'm going to be telling people that I know what a compressor is. I'm going to go, you know what bicycle pump is? So I'm going to...
Yeah. And if I should explain it on the bicycle pump, the bicycle pump is pumping the air into the wheel and extend the pressure based on compress the volume to a higher pressure and compress this volume. And based on this function from inlet to outlet, you increase not only the pressure, you increase also the heat. And that is the principle of how the compressor is working. Not only the technology of AERZEN with screw compressor and roots blower, also the other parts. Because so long you have a gas, what you can compress, liquid is not compressible, then you create also heat. And our machines are working in process where it is needed to increase the pressure for the process which will follow or where it's coming from.
Yeah.
Sometimes it will be working from atmospheric pressure to a higher level or from higher pressure on the inlet side to the outlet side. And every time you increase the pressure, nothing more will this machine do. Very simple.
And you said it can go maximum 10 bars, is that correct?
No. The ratio is up to 50 bar, what we
50?
can. Yeah, but this is depending on differential pressure, because then you look more or less in the technology. Once is how the machine is working, and on the other hand, what is the technical limits. Technical limits means high pressure will cause forces on bearings. Such a machine, our machines are two shaft machines, which are working in parallel together to compress the gas. And the shaft has bearings so that they can turn smoothly with different speeds, of course. Yeah, different speeds means different flow. And these bearings will be designed based on the differential pressure. The differential pressure is a force which bend the shaft. The shaft is nothing more as by this bicycle pump, the shaft where it's going in and out. in and out.
Yeah.
So, and that is positioned with bearings. They take care on the forces. And this rotation of rotors is free without any touching of the housing. There are small gaps inside, and we have to take care that the forces on the rotors are not so big that the bending will touch the housing. Because if it's touched the housing, you damage the machine.
Yeah.
Simply to this air pump, this head where you press the air out of the pump has to have a gap that it can run and move inside the housing of this pump.
Yeah.
So it's similar to a compressor. And this differential pressure will limit the bending of these rotors. And we have different differential pressure, which we can handle. And you can imagine if the bearings, we have two bearings on left-hand side, right-hand side, and if the distance is much longer, the bending is, the forces can not so high, because the bending will be much more. The distance between the bearings are important.
Sure.
Based on the length of the rotors, we have differential pressure for these machines, means a long distance for a short differential pressure and a short distance for higher pressure. And we can use these machines up to 50, but not in one machine, also as a multi-stage. If we come from, let's say, atmospheric pressure and want to go to 50 bar, then it needs a multi-stage solution, step by step.
Okay.
And it will be from the size, the biggest size in the beginning, smaller size at the end.
How many years now are you at AERZEN? How many years in total?
In total, this year, 160 years AERZEN. It started as an agriculture company in 1864. And then beginning of the 19th, we started with roots blowers. The first one as a wooden make rotor inside with a ladder ceiling on top of the head of these rotors. And after the Second World War, we started with the screw compressors, all three. As we discuss it today, very often all three compressors are the most common one. It follows by an oil-injected screw compressor in the end of the 60s, mostly for refrigeration. And then it was modified to go also in process gas.
Okay.
Oil injected, oil free. That's the typical design of this screw compressors. For process gas as well as for air applications. For process gas, it's more specific in some details inside sealing system and so on. And the principle is for both the same. It's a screw which is turning together and will create a higher pressure at the end of this machine.
How long are you with the company now?
More than 30 years.
More than 30 years. When you joined 30 years ago, what's changed?
I started to write telefax, and nowadays we have email and Teams and so on. So this communication changed from the technology. The principle is the same. The material changed a bit, so we modified that we can use different materials. Not so much, but yes, they changed.
Yeah.
And what is different? Yeah, sealing system is quite an important issue. In the past, it was more or less a simple sealing by rings, and now you have a mechanical seal, which is really tight. Also, if the machine is not in operation and you have no sealers. That's a typical development of these machines, especially for process gas. Yeah, that's what has changed. The machine, of course, in size and bearing designs, you have smaller changes, but the main part on these machines are the sealing system.
That's it.
Yeah, but this is not an easy, simple thing. Yes, of course, by an air pump, it's simple. It is working like a motor cylinder, and the piston, what is in with the rings, what you have around this piston to take care from the oil and the compression room. It's similar to the screw compressor, but based on this very dangerous gases, we have to take care that there is no leakage to the outside.
Yeah.
Also, mostly no contamination with the oil, because the oil is the important issue to lubricate the bearings.
And I was just going to follow up on that. For example, can you tell me the application and the high risk involves with the compressor, like with the gases, what's involved in that scenario, like the dangers that will come with that?
Yeah, the dangers is the combination of the gas mixture. There is some gases which will have effect on the humans, on the and on the environmental in any case. So that this area where these machines will be installed, especially process gas, is an explosion-proof area.
Okay.
That is certified by the customer, which area he has to consider. And it is important that these gases will not go out of this machine. So the process is that we suck it from the process and give it to the next step of the process.
Okay.
So, and in that case, we have to take care that there is no leakage outside, and because otherwise it can explode. If some operator is in the near, it can happen that they die.
How big of an explosion can it go? How big can it get?
Explosion you can have if you have air. So long you have the gas inside without any air, you have no explosion. So, and the explosion, there's explosion pressure that is mentioned in a table, is maximum for atmospheric 1 to 10. So if you have a discharge pressure of 10, the explosion pressure could be 100.
Okay.
So, and the energy, what is coming from this, I cannot say in detail, because that's typical of each individual gas.
Yeah.
And we have to look on the mixture of the gases.
Can you tell me some of the things I would be surprised that your compressors are in that I wouldn't expect? For example, I heard like you have a compressor in CERN.
Yeah, we have a compressor also in CERN. That is, as I explained, it is a package and a part of a process. In CERN, we have oil-injected screw compressor packages, which are working in a helium process. Also as an package where we compress the helium. I'm not detailed informed at the moment, but from the inlet to the outlet pressure on a certain part, and that is something what we do there. Similar to the DAISY part, it's also a research and development institute in Germany. DAISY is in Swiss.
Yeah.
And there we have the same installation or a similar installation, all injected.
But is it with those kind of compressors, would they need more maintenance or more scrutiny because of the situation they're in, or are they run the same operational wise as one for, say, that's in UAE or normal?
Yeah, the difference to what I explained before is that helium is more or less a neutral and clean gas. So, and that is a circulation more or less where it's working, this machine. The maintenance in that case is not so needful, let's say, on the oil side, because oil injected are a compressor which is working with the gas together. So you have the gas also in the oil. And if you have an open process, then the oil can be from the viscosity dropped down, and viscosity is important for the bearings. And you have to take care on it. Therefore, you can have more maintenance. In these processes by DAISY or by CERN, you have an helium process which is clean, and it's in a closed loop, and the maintenance is quite less in that case.
Okay.
So that is
less.
That is something what you have to look for. If you have a closed loop, it's a bit easier for maintenance for these compressors. If you have an open loop where you have gas which is dirty and with components, you have a bit more maintenance because it will involve the oil quality.
Yeah.
And oil quality is for oil-injected screw compressors much more important.
But it must be proud. It must be like the fact that your compressors have been selected for Daisy and CERN. That must be...
Yeah, that is a special thing by oil-injected screws. The process should accept oil. Small amount of oil, but there is oil inside the process. And if the process can accept it, and cooling processes can accept it, there is this machine are, let's say, designed for in the very beginning, then there is no concern on it.
What are the advantages of process gas solutions, compression and transportation here in the UAE? And again, with this, what is the risk and how safe is the technology?
Well, the petrochemical industries work with similar gases and similar pressures already for decades. So the local know-how is here how to handle gases.
Yeah.
What is not there is the new infrastructure you need for the transportation of the CO2 and the hydrogen. And this is going to become huge.
Is that a separate wing of it? Like the actual just transportation of it? Like, is that a...
The difference is the quantities and the distances.
Okay.
So there were not large hydrogen networks overland before. There's one only pipeline for CO2 gas installed years ago in the United Emirates. The magnitude of this project is gigantic.
Okay.
ADNOC yesterday announced the plan of 10 million tons of CO2 sequestered annually by 2030.
Right.
That is very, very soon. And 10 million tons is a lot of gas. So very, very huge. So you need machines to do that. You need to do the pumping. You need the tubing, the energy supply.
Are these all separate companies?
Nobody got it all.
Nobody has... Oh, okay.
So there's space for everybody, and this is a new market. Large-scale handling of gases. Before, that was done with natural gas, transcontinental pipelines, but they were feeding themselves. You burn part of the gas. You had a gas turbine, same like for energy generation aircrafts, and they run each other. So it run itself.
Yeah.
Now you need to run the pumping with electricity. So again, we will have a huge need for additional electricity production for pumping and compression of gases. And we're not talking about few megawatts, it's hundreds of megawatts. Of additional energy capacity, which we have to provide. And yes, of course, best case, it's not from burning more hydrocarbon.
What's the dangers of transportation hydrogen as opposed to natural gas? And is there more dangers? Are dangers involved? Is there more protocols? Is there more safety? Is there more... Are people not trained enough? Is it the whole industry is in its infancy? Or is there... It's all there, but someone has to put the pieces together.
There are slight differences. Of course, natural gas pumping is well known and the dangers are well known, and some accidents happened. Mostly when the maintenance was not done properly, or when people crash into pipelines, drilling into pipelines.
Yeah.
That causes accidents.
Yeah.
And that's unavoidable. That you have security protocols, you have to do your work fine, and then nothing should happen. The difference is hydrogen is the smallest molecule you can get.
Okay.
So by definition, it likes to get out. While methane is pretty large and it's easy to be kept inside, even for longer periods of time. So what you need is very high quality materials at a higher quality level than for natural gas. With CO2 again, you have the problem, the CO2 in the mineral water bottle, it's acid. So it can cause corrosion.
Right.
So all that has to be taken into account. But in general, everybody knows in the industry how to handle high pressures. That's nothing new.
So it doesn't really change that much.
That won't change. What changes is the magnitude. This is going to be a whole new sector of transportation and infrastructure.
But with the whole new change, is it everything has to be redeveloped or developed new? So do we need special new trains? Do we need special new ships? Do we need special new, or can they be converted to what we already have?
Now, I doubt that you can convert the existing shipping for hydrogen and CO2.
Okay.
They're all custom made for liquefied natural gas, which is different. It's, let's say, we can build up on experience.
Okay.
So it's not from zero. We have transportation networks for hydrogen, for CO2 in the United States.
Yeah.
So the engineering parameters are clear. What is not available is magnitude of equipment produced to comply with that new infrastructure needs. So it's again the game, who's going to produce the stuff?
Is that where we talked about before? Is that another pushback? Like, even if you develop the hydrogen, the network, you still have to then develop the shipping, you still have to develop
the whole chain is a new business.
A whole new business.
Everything has to be scaled up.
Is that the scary part, you think, for investors or for people? Like,
that should be scary. That's a good chance to develop a new business.
yeah.
And it's not just production of the hydrogen. It's not just renewable energy. It's the whole value chain, the whole transportation networks, the pumping, the valves, everything will create new demand. And if you have a good solution, if a good technology, you can open up a new market for yourself.
Would you invest in it?
I already invested.
Oh, really?
I invested on the side of hydrogen production.
Okay.
In solid oxide fuel cells, which can also work in reverse operation. And
Now, explain, because that's
what
very,
is it? Yeah.
that's very technical.
Yeah.
I am a caveman. So explain that to me, what you've just
How to produce hydrogen.
right.
There's currently 4 ways how to do that.
Okay.
The classical way, you heat up natural gas until the natural gas dissolves in hydrogen and CO2. So that's how to make the bulk of the hydrogen is done in the moment based on fossil fuel. That's a known process, done millions of tons. Then everybody's talking about is the green hydrogen, which usually is done by electrolysis. That's the school experiment,
Okay.
where you put electrodes in the water and then it bubbles and then it makes boom.
Okay.
That's a typical electrolyzer technology. It's cheap, it's available, it's known for 200 years how to do it. The disadvantage is efficiency.
Right.
Of course, you cause a lot of waste heat. Also, the bubbling is a problem. So there are solutions, they improve, but there are physical limits
Okay.
to the efficiency of the system. Then the thing came up with using fuel cells. So the typical fuel cell everybody thinks a fuel cell is you put hydrogen in and water comes out and you create electricity. That's what you put in the hydrogen trucks, hydrogen cars. That's called a PEM fuel cell. And those work on pure hydrogen. And you can also create a PEM fuel cell to produce hydrogen out of electricity. So this is the next step in the development. So companies like Siemens build now gigawatt factories to produce PEM electrolyzers for export.
Okay.
And the latest move in the market is the solid oxide fuel cell. This is also a well-known technology, but now it gets a boost by being able not just convert natural gas into electricity at a very high efficiency. These fuel cells can also produce at a higher efficiency the hydrogen, because they operate at high temperatures, and the high temperature enables a fuel cell to work as a membrane to select gases. Right.
So you press through the oxygen, or the oxygen is actually sucked out of the ambient air into the fuel. And while it's going through the membrane, the electrons fly off. That's how the fuel cell produces electricity.
Interesting.
So when you reverse that process, it works only on a high temperature level. You can add thermal energy, and the thermal energy becomes a part of the chemical energy you produce. And that's why you have this extreme high efficiencies of up to 90%. Conversion from electricity to chemical energy.
This is what you believe is the...
That is 30% better than all the other alternatives.
Oh,
And the advantage is it works indifferent from ambient temperature. So you run it in the desert, you run it on the North Pole, you always have the efficiencies. And technically challenge is to make it long-lasting. So the breakthrough is to slightly lower the operation temperature so you can use conventional steel for the production. You don't need to have fancy space-age materials anymore.
yeah.
Which cost too much in mass production. So the question is make it cheap and make it durable. And once you reach that, then you have a super efficient solution.
Is there any pushbacks, or is it just, why is it not more massed? Like, why is it not?
It's a newer technology.
Yeah.
It's not really established in the market like the electrolyzers, which are there for 100 years. This is new. You need large factories to build it.
Yeah.
There's now several companies in the world which start production on large scale, and it's the market leaders in hydrogen production choosing that technology over the electrolyzers.
Do you find with compressors and these other technologies, is there a difficulty in finding people to train and maintain these? So, for example, like you're saying, like for the new hydrogen, you're going to need certain people who are going to have to be trained up on all this. Same for you have people working on CERN. Would you find that again, the people in the industry is difficult?
The kind of work is totally different. So for the operation, actually the new technology becomes more simple. When you had diesel generators standing around everywhere in the Emirates for the cellular telephone system, for example, there's plenty of generators. The new technology becomes much easier. You don't need a grease monkey anymore. It's distance controlled. It's all computerized. It's all networking. You can leave it alone for a year and don't maintain it.
Yeah. Is that the same for your technology as well?
Yeah, that is the target.
That's the target.
That's the target for the customer, to have not the operator besides the units. We prefer and recommend it because it's rotating equipment, it's a running machine, and to look after this machine. But the target of the customer is to reduce this people so much as possible.
Okay.
Yeah, we have a project now in Australia where the target is to do so of a long time, 3 years and more, because the distance between the control station and the machine is more than 30 kilometers, and the operators come every 2 or 3 weeks. So it should be safe enough that this machine can run.
Interesting.
So logistics and maintenance can be a decisive factor.
Absolutely, yeah.
There were studies for the American army deploying in Iraq. And guess what is the biggest job of the army when they went to Iraq? It was fuel logistics. And for what did they use the most fuel? Running tanks? No, actually not. Power generation. And what was the biggest uptake of the power generation? Air conditioning. So actually, the biggest part of the military operation of the US Army in Iraq was shipping fuel for air conditioning. And the fuel became horrendously expensive once it traveled from Texas to the tent in northern Iraq. And
it's exorbitant expensive when you calculate all the chain which comes in, including the Apache helicopter above the convoy protecting it from attacks.
Yeah.
So it gets horrendously expensive. Sometimes the fuel is flown in by helicopter to remote locations. So if you have a machine that reduces your fuel uptake by 50% and doesn't need to have lubricants and can run for a year, and on top of it is totally silent, that's a huge advantage.
Yeah.
And as a military, you want to have that.
Yeah.
Because all your logistics is increasing your target. So you can be killed easier when you have a logistic chain. So from that point on, you can say, okay, same is of course for commercial applications. When you are a telecom company and your main occupation is to shift fuel around and grease diesel engines, wouldn't you like to have a technology where you can see on a nice screen everything is fine? Oh, there's one fuel cell which doesn't work, but we have 3 others in parallel, so we don't need to care. Everything is good. And you run it for a year, and then just somebody shows up and changes the air filter. This is much nicer than all the services you need for diesel generators.
Yeah.
So they work also fine with solar. So the combination of fuel cell and solar increases the range of the fuel you have in the tank. So it's like a backup or always on, but not always consuming energy source.
Yeah.
And it's easily to be paired with solar. It's all automatic. It's all clean. Nobody will mention it because it doesn't do any noise, no vibrations.
Who's leading the innovation in this? Is there any particular place, or like is the UAE embracing this, or is there Saudi or China or Europe? Who are the ones pushing this?
Initially, of course, Europe and US were leading in this technology, but the follow-up was missing.
Right.
So for, as usual, 20, 30 years, they received subsidies for development of the technology, and then the implementation stopped.
Yeah.
At that point. My friends were working for 10 years with Saudi Arabia, and Aramco showed huge interest in this because you can produce electricity directly on the oil field, and the fuel cells nicely separate the CO2 from the natural gas when you make electricity. And the CO2 doesn't need to be transported in this way. You have it already on the top of the oil field. So you press it down instantly, and the CO2 will liquefy the oil underground, like paint thinner.
Wow.
So you increase the pressure, you increase the amount of oil that can be recovered, and you get rid of the CO2 emissions at once, while producing silent, reliable electricity without operation personnel.
Right. That sounds amazing. So why hasn't America and Europe pursued it? Surely, if it's that good and it's doing what it's doing, why wouldn't America want that for?
Oh, Americans are doing that. For example, Google, Microsoft, they invested heavily in fuel cell technology. And Microsoft also was running natural gas fuel cells in parallel with servers. And the fuel cells can follow the energy uptake of the server without any buffer in between. So you economize in the construction cost of your data center.
Yeah.
Which otherwise needs a lots of technology. You cannot just take grid power, because then suddenly your computer is off, yeah?
Yeah.
You need always to have backup in order for everything not to even be off for half a second. You need battery packs, buffers. And you go from high voltage to DC, then you go to 230 volts again, and then you go to 12 volts. Lots of energy is wasted just by transforming up and down the electricity and the voltage.
Yeah.
While with the fuel cell, you do the 12 volts your server needs directly. No loss. Hundreds of fuel cells working in parallel.
Yeah.
So if one is failing, nobody cares. It's one grid. So you can operate data center with natural gas. You can separate the CO2. And in this way, it's a zero emission data center, super efficient, super reliable. Because if you use solar, what do you do at night? You anyhow need a backup.
Yeah.
So in this case, you're using the natural gas for a high value application. It won't pollute.
No,
You have your zero energy, zero CO2 footprint. As long as you put the captured CO2 back to the underground.
I don't understand. Like, if it's that good and it's that simple and it's that,
The production capacity is limited. There's a few companies mastering this technology.
yeah,
It's not easy for competitors to get into that market because you need a decade of experience.
so who do you need into the market? Do you need the Chinese to come in for the prices to get lowered, the technology to? What would it take for that?
Well, if you like the Chinese to also capture that market,
But will they eventually?
I always say that the Chinese are coming surely.
Yeah,
They will copy that technology. They will also introduce it. China itself is a gigantic market for it.
yeah.
But it's a still unclaimed price. So there's not a dominant producer in the moment. It still can be done by investing in a localized production.
Okay.
And it's ideally done in a country with a large domestic market, with big players that could uptake the full production of this facility. So there's no risk. You will produce and you will know they can sell. It's a Gulf country. All the factors are here.
That's where you're betting on it.
I guess why I'm not in Germany.
I thought it was because of the weather. So that's why. Yeah.
Yeah, I'm here because of other.
Oh, okay. Good. Very exciting. Where do you think will be? I always ask this because I always think it's interesting. But where do you think? How do you see it then in 10 years? That market that you're talking about, 20 years. When do you think it will become mainstream?
This technology can replace actually all the gas turbines we have in the moment. Because when you want to make real clean electric power with natural gas, you should capture all the carbon emissions. So you have to compare the cost of natural gas power generation plus CO2 capture. The fuel cell has built-in CO2 capture. Then the fuel cell can be made in a factory, containerized. Every several hours, you have 1 megawatt leaving the plant.
Yeah.
So it's easy to be deployed. It can be scaled up. You can build more capacity time by time. You can operate very quickly, while Saudis had a national program, and it was performed by their National Institute, King Abdulaziz City of Science and Technology. They were already having field tests with fuel cells in a real operation environment. And that process already goes for 10 years.
Wow.
So this is about to happen.
Yeah.
And the question is, will have the Emirates the necessary speed to keep up?
Do you think they will?
They could. The nice thing about the Emirates is we don't need only to think about the local market. This is more open, export-oriented. I would suggest not only to think about the local consumption, but also for all the investments outside the Emirates. Masdar, as an example, hundreds of megawatts of renewable electricity developed outside the Emirates. So with this technology, you can do the same.
Okay.
So you can provide the finance, the know-how, the core technology for projects all over the world in similar circumstances. So this could be a way of the Emirates to become a market leader in carbon removal, carbon sequestration, but based on a hydrocarbon technology. So this is not like in Europe when we say you have to have the hydrogen economy. This is a kind of universal device. You can use it with hydrocarbons, or you can produce hydrogen. Both is possible with the same core technology, and it's the bridge between the technology and the resources we have now, and even the far future when you go entirely based on renewables.
Yeah.
Both is possible, same technology, same factory, same guys. So that could be a very smooth conversion from the hydrocarbon age into, let's say, the clean hydrocarbons, the blue hydrogen, and then finally the green hydrogen.
All possible.
For the next decades. So the nice thing is you have no lost investments. It's the same machines, the same plants, the same people can do both.
And then you think that should be the goal, or that is the goal?
My personal goal would be to have a machine that can do all at once. So imagine, it's night. The sun is not shining, definitely, at night. But you have lots of natural gas. So you use the natural gas to produce power, and you have hydrogen. Same time. While the CO2 you separate. Now it's morning. Okay, you still need electricity. You start having photovoltaics, so you choose. Either you continue to produce electricity from natural gas, or you slowly, when it comes to noon, start producing hydrogen in reverse operation. So you take the surplus photovoltaics and turn it into hydrogen power you can store. And in this way, you can operate the same machine 24 hours a day, and it either produces fuel or it produces electricity according to the grid uptake. And this helps to smooth out the fluctuations of renewables. And this type of machine you will need everywhere in the world. It's much more efficient than using batteries. Batteries are great for fast and short-term fluctuations in the grid.
Right.
But they are awful when you want to store electricity for several days. So you need the fuel cell for the medium, let's say, energy storage, and the long-term storage, of course. And that's a gigantic market.
Yeah.
So this is the final step for the full decarbonization of the power system, and you integrate your fuel generation also in it. Takes care about all the problems you have.
Fingers crossed.
Yeah, it's not a question of science and technology anymore. It's a question of political will and available finance.
Yeah. Do you think the Gulf states will surpass Europe and America? Like eventually there's going to be old world and new world when it comes to this technology?
That is absolutely possible. Europe is moving slowly. It still has the lead, but it's very bad in starting large-scale production. Is there a large-scale production of photovoltaics in Europe anymore? It's gone. So the same can happen with the fuel cell. Europe paid hundreds of millions in development for that technology. And the technology is now ready for deployment. But do they have the Europeans a market for it? So the Europeans want to get off the natural gas consumption. So I doubt that the Europeans will invest heavily in the solid oxide fuel cell technology. This is a technology for a country with hydrocarbon reserves because it's universal. You can use the hydrocarbon and you can use the excess photovoltaic electricity. Both. The Europeans not really need that. They want to go hydrogen only,
Right.
without the hydrocarbon. So that's the chance for the Middle East to take the lead in this specific technology because it fits perfectly to your local requirements.
I hope I'm still here for it when it all kicks in now. I want to be, want to see the advantages of it. Because the advantages can go long reaching, can't they? Like when that technology kicks in, if it goes full scale,
Oh yeah, this is going to be used in many fields. For example, shipping.
Yeah.
So you can run the next generation of ships which have ammonia tanks, and the ammonia pot to propel the ship.
Yeah.
So the fuel cells convert the ammonia directly into electricity, better than any engine ever would be able to do so.
Wow.
You could use it in locomotives. There's some limits of application. For example, don't put it in a car because they need some time to heat up. So you don't want to wait 3 hours before you can start your engine.
Okay.
So this is an industrial application.
Yeah.
That's perfect for always on baseload. Ships are baseload.
Yeah.
They run for thousands of hours per year. Heavy lorries, trains, generators for the cellular networks, data centers. Guess how much energy uptake the data centers will have in future?
Yeah, I can
It
imagine.
is several percentage of the world's power generation, which will just be used for data centers. So for this specific applications, it's a perfect solution already on the short term. Well, when you say you want to see it, there's nothing to see. It's a box. It doesn't do anything. No vibrations, no steam coming out, no noise, just simple. It's just there.
That's like me. I'm just here. Gentlemen, thank you so much for your time. I'm very excited. Every time I speak, especially if I speak, I always come away with this going, this is... Because I am... Best way to describe it is outside the loop. And then when I speak to you guys and I hear this technology about compressors and CERN and you know, hydrogen and all this future, it's very exciting. It's very exciting. So thank you very much.